Lesson 10 has 3 topics: division by zero, exchange of factors and multiplication, and conversions of area. The first topic we'll take up is division by zero. Division is the inverse operation of multiplication because it undoes multiplication. So if we have 3 times 2 equals 6, when we divide 6 by 3, the answer has to be 2. We have to be able to multiply our answer by what we're dividing by. Okay, so 2 times 3, and it must equal 6. Okay, I'm going to get a little bit wider line for this. Okay, now if we divide 6 by 2, we also have to have that 3 times 2 equals 6. What's 6 divided by 0 then? We can't tell, okay? One of the logical answers would be that it would equal 0, but 0 times 0 is not equal to 6. It equals 0. Another logical answer, if we have 6 divided by 0, would be 6. But 6 times 0 does not equal 6 either. Anything times 0 also equals 0. So for this reason, we call division by 0 undefined. Thus, 6 divided by 0 is undefined. 0 divided by 0 is called indeterminate. Thus, 0 divided by 0 is indeterminate. Indeterminate means we can't tell if it's undefined. Might be undefined because we already showed that we can't divide by 0. But again, anything over itself usually equals 1. Does it equal 1? We don't know. It's one or the other, but we can't tell which. 0 divided by any real number is 0. Okay, so 0 over negative 2 would be 0. 0 over 435 would be 0. Okay, so this we have 4 minus 2 minus 2, that equals 0. 0 over 13, the answer is 0. 13 over 4 minus 2 minus 2 would be 13 divided by 0, and that would be undefined. That's your answer. If you see the 0 in the denominator as the divisor, it's undefined. Okay, exchange of factors and multiplication. The order in which signed numbers are multiplied does not affect the answer. This is called the commutative property of multiplication. If we want to find the product of negative 4 times 3 times negative 6 times negative 2, we can do this. Let me get my grabber tool here. Okay, 4 times 3 would give us negative 12. Negative 12 times negative 6 would give us negative 72, or positive 72, I mean, because it's a negative times a negative. And then 72 times negative 2 gives us negative 144. Okay, now negative 6 times negative 2 is going to be positive 12. So then we would have positive 12 times the 2 remaining factors, 3 and negative 4. 3 times 12 is 36, and it would be times the remaining factor, negative 4. And negative 4 times 36 is negative 144. So even though in this problem the 6 is no longer number 3 factor, it's number 1. Negative 2 is no longer the 4th factor, it's the 2nd. 3 is the 3rd factor, and negative 4 is the 4th factor. What do you think the answer is going to be to this? Again, we've just rearranged those factors. Negative 6 is first, Negative 4 has moved to second, 3 has stayed in third, and negative 2 has gone back to fourth. Okay, so negative 6 times negative 4 is positive 24 times positive 3 times negative 2. That equals 72. 24 times 3 times negative 2. And again, that equals negative 144. So mixing up the factors does not matter. In fact, some people like to multiply all their numbers that have one sign first. And when that happens, let me see if I can get my pen's not working at the moment. There we go. Okay, so maybe if I put them like this, negative 6 times negative 2 times negative 3, I know if I have an odd number, sorry, that's a positive 3, and negative 4, I know if I have an odd number of negatives that it's negative. So I can just multiply across and make the whole answer negative. Okay. Next. Okay, we want to use 2-unit multipliers to convert 44 square inches to square centimeters. This is conversions of area. We've done conversions of linear units. When we have 44 inches squared, it's just like writing a number to the second power. If we have 7 to the second power, it means 7 times 7. If we have inches to the second power, it means exactly the same thing. Inches times inches. We then need 2-unit multipliers to cancel out the inches unit. We know that 1 inch equals 2.54 centimeters. Okay, remember, if we have inches in the numerator, our inches have to be in the denominator in the 2-unit multipliers. This will cancel this inches, this will cancel this inches. We have nothing but ones in the denominator, so we can omit the denominator. And we're going to have 44 times 2.54 times 2.54 centimeters squared. You could even write this as 44, oops, I need a pen to do that, as 44, and instead of writing 2.54 twice, you can write that with the power as well. Both things are exactly the same answer. Okay, we're going to use 4-unit multipliers to convert 125 square centimeters to square feet. We write 125 square centimeters as 125 centimeters times centimeters. Whatever we're converting, we always put over 1. We make 2-unit multipliers that have centimeters in the bottom. I can cancel out the centimeters now. They're gone, just like a number. This is the unit multiplier that goes with centimeters and takes it from the metric measurement into the British measurement. We want feet, which is a British measurement, and this is like our bridge to get into that British measurement. 1 inch is 2.54 centimeters. We know we need to cancel out inches, so the inches in the next pair of unit multipliers goes in the denominator. We cancel that, and then we cancel this. And we have 125 times 1 times 1 times 1. That's going to be in our numerator, and that's going to be the only factor in there. And in the denominator, I'm going to write it with exponents. I'm going to have 2.54 squared and 12 to the second power and feet to the second power. And that's our answer. Okay, this concludes lesson 10.